So going to our last slide, no? So I think this is just merely, seat work already, no? Now there's a last lesson there which is about the certain Gauss principle, no? And it simply shows to us, no, ang last lesson there, no, on our so this is an exercise already, no? So but nonetheless, no, if we try to look at the last chapter, no, of our lesson for our module, no? So there's Gauss equation here that we are going to derive, no? Or maybe some Gauss law, no? And it's simply telling us that there's these lines of forces that are coming out of a charge, no? Now how many or how dense they are, no, will determine what we call a flux, no? So nonetheless, no, this is too computational, no? So we are talking about a number of charges here, no? I don't know. We are talking about lines of forces that are coming out, no, of a certain charge, no? So this is a bit mathematical, no? Because again, no, we are dealing with, no, charges that and no, some plates or plate capacitors, no? Now we are talking about plate capacitors because we will discuss, no, in the next chapter uh, the lesson on how significant are capacitors, no, in our discussion, no? So we'll be learning here, there's a certain um, amount of lines of forces that are coming out, no, on a certain area of a charge, no? So if you look at the surface of a charge and imagine it as a sphere, no, we'll see that there are lines of forces that are coming out, no, if it's a positive charge, no? And therefore the concentration or the number of these charges present, no, in a given area, in the surface area of a charge, will determine its thing we call as its density, no? The density of the flux that are coming out, no? So the more charges or lines of force that are coming out, then we realize that it will exhibit a greater force of either attraction or repulsion. There would be a greater degree for its electric field, no, and its intensity, no? So again, no, this is highly, no, mathematical in equation. But again, our main essence or main point here is simply, no, to know the strength of the field, no? So what is also mentioned in this Gauss law is that the electric field, no, inside, no, or the electric field outside of our charge may at some point, no, become zero, no? So if we deal with the charge or the electric field inside here, no, then there's none, no? So that is if our r, no, is less than the length of the big letter R, which probably, no, represent this this region of our electric field, no? So if that happens to be bigger, then there might be a value, but if it's inside, no, this region here, then there's no electric field inside this, no? Now if you deal with a certain straight wire, no, so the electric field here will be affected by, no, this certain magnitude called lambda, no? And to some extent also, no, it will also now be affected by this length, no? Again, no, the length of the wire, no? So this length of the wire happens to be inversely proportional to lambda, no? So longer wires, no, will tend to have, no, a probably, no, a lesser value for the electric field, no? So but anyway, no? So for today, I think now we will just end with that lesson on electric field, and next meeting we will discuss about, no, the discussion on maybe dielectrics and on the discussions on capacitors, no? So we will see each other on Wednesday, no? So God bless everyone, no? And good morning. Let me see, no, those who are still who are present.